Hi, I'm Jared Sandman, President and Creative Director of Autoblocks. And today what I'm going to demonstrate is the manual loading of a Autoblock machine. What we have here is the TurnBlock 24, which is our smart indexing table, which has your HMI PLC and your entire control system inside the TurnBlock. We have an enclosure on top. We have an Epson robot in the back doing a pseudo process, in this case screw fastening. We have our ASG XPAC controller, and we have our Keyence IV3 vision sensor. Just going through the front of the machine, what you can see here is you have Keyence light curtains, which are plug and play with factory metric cables. So there is no power supply, no relay that has to be set up. That's all already built into the TurnBlock 24. And then we also have our door switch. This is an RFID door switch, which is also plug and play with metric cables. The Keyence IV3 is plug and play over Ethernet IP and also powered by the Autoblock. The Autoblock powers itself, the PLC, the closed loop stepper for the indexing table, as well as the Epson. That's all powered through the Autoblock. So now what I'll do is I just want to go over the front of the machine. So what you see here is your interface for your operator. So obviously ESOP powers down all motion. You have your power disconnect with lockout tagout. You have your machine network. Inside the TurnBlock, it has a machine network which connects all of your devices, including the PLC and HMI. Here you have your touchscreen HMI, and you also have your physical start and stop buttons. Now, if we look at the HMI really quickly, what we've done here at Autoblocks is spend a tremendous amount of time developing very simple and intuitive HMIs. Basically all icon driven and as much as possible without words, so any operator can understand it. So if we go from top to bottom looking at the HMI, first you see is a status bar. This status bar we find is very, very useful because it always indicates what's happening with the machine. In this case it's gray and it says stopped, but we also use the status bar to indicate fault, warnings, and it has words on it that indicate what the warning is. Then across the top here you have your Autoblocks logo, which always takes you wherever you are in the HMI back to your home screen, so that's an easy way of getting back home. And then you have your reset button, so if you have a fault, you hit reset. And if the machine goes back into fault, that means there's something that you actually have to correct. You have your fault icon that takes you to your fault screen, which gives you your details on what is actually faulted. You have your gear icon, which takes you to a simple settings screen and has all the settings for the machine, including the speed and parameters for the gearbox and the motor. And then you have your recipe icon. Moving down the screen here, you see a big circular white disc. The circular white disc is a graphic representation of your actual turntable. And on the turntable, on the white disc, what you see is 4 icons that indicate the nests. In the center of the white disc, you see a home icon. The home icon indicates the status of the motor and if it has home position. And then each of the nests have an icon that lights up green when there's a part in the nest, and also on the lower operator load position icon, you have an arrow that indicates when you need to load a part and when a part is ready for unloading. And you'll see in a moment when we do the demonstration why that's important. Because with an indexing table, you have to know where the parts are at all times, and you also have to track the parts. Moving down to the bottom of the screen, you have your digital start and stop buttons, which are obviously the same as the physical. You have your auto function, which is the mode that you're going to be used for processing parts running in auto. And then you also have your pack out or purge function, which allows you to continue to process parts while unloading the machine. So you use that function at the end of a shift. So what I'm going to do now is I'm going to start by demonstrating the loading sequence. We think this is really, really important because a lot of processes are hard to automate, and you need an operator to be able to physically put parts together, and then you want to run a highly capable, high-speed robot in conjunction. And the way you do that is with these very carefully designed loading sequences, which integrate the PLC, safety, light curtains, table, and the IV3. All these things work together seamlessly to make sure that you're safe and you have parts that are loaded properly and you're tracking them. So what we're going to start with is I have 4 wooden blocks in my hand with different color sides. We have a red side, which indicates the first part of a 2-part assembly. So if we put this in, the machine should recognize it and not index. Then we put the blue side up, and the blue side indicates 2 parts of a 2-part assembly, i.e. fully loaded and ready to index. Then we have white, which indicates that the part is fully processed and correct, meaning it's gone through the screw fastening process and all the screws are present. And then the other sides are natural, and if we take a look at these with the camera, it doesn't fit the profile and you should get an error. So I'm going to go ahead and demonstrate that. So the machine, we can see, again looking at it, we can tell that it's in a stop state and it's ready to begin. I hit the auto button and I hit start. You can see that the camera takes a picture just to initiate the sequence, and the status bar turns green and it says running. So I can tell right away, and the light tower has turned green. So what I'm going to do is I'm going to load the red, which is the first part in a 2-part assembly. I put it in, it takes a picture, and nothing happens as expected because it doesn't have enough parts to actually process. I'm going to take that out. I'm going to put in the blue side. Blue side represents a full assembly, and when I take my hand out, the table should index. Okay? Now I follow the process again. I put in the first part of a 2-part assembly. Nothing happens. I take it out. I put in the blue part, which represents the full assembly, and I index. Now you'll notice on the HMI, there's 2 green parts lit up on the icon, or the white disc that indicates that there are parts tracked. You also saw the robot process the first part. It's just a quick motion. We're actually not screw driving today. So that part is processed, and you can see at the bottom here, there's a green arrow that indicates it's running and it's ready to be loaded. So now what I'm going to do is I'm going to put that red first stage in. I take it out, it takes a picture. I go back in, I put in the second part, and it takes a picture and it indexes. Now I have 3 parts in. I go through the process again. This time I'm just going to go to a full assembly because I put the parts together, let's say in my hand, instead of putting them into the machine twice. I put it in, I take a picture, and I index. Okay, now here we have a white part which indicates that it's completed the process. I've staged another white one behind it, and now you can see that the icon is pointing up, which indicates I need to unload it. I take it out, it takes a picture, and the arrow points back down, turning green, indicating that I have to load. Put another part in, and you should see it index. Takes a picture of the white part, and it indicates it needs to unload. Now, I take this out, and let's put in a natural part, indicating an error. And we see that warning again. It says part failed warning. Okay, now, and when I take it out, it resets automatically. I want to demonstrate a couple more things. What we're going to do is we're going to demonstrate the purge function now. So if I press the purge, what it'll do is take a picture, and because what it's looking for is no part, because we're purging the machine. It indexed. I take the part out, and you can see it process the part in the rear, and it will index again. Basically, it goes through the whole routine, allowing me to clear out the machine. Take out another part. I now have 3 in my hand. And I take this out. I turn off the purge function, and we're good to go. Now, one thing that's really neat is if you're doing process development, you can actually use a purge function to run a single part. This is a really neat trick. So right now I'm in the running state. I'm in auto. If I put in a part, it will index. If I put on the purge function, it will continue to track that part. You can see it going to the rear. Robot runs, it processes that part. And then it'll keep indexing. You can see it's now in the rear position. You can see the parts in the rear position. And it brings it back to me. I turn off the purge function so that when I take the part out, it doesn't index. And look, I just processed one part. This is a perfect trick when you're doing process development. The next thing I'm going to do is I'm going to demonstrate a couple of safety features. It's in auto. It's running again. I'm going to put in a part. And it indexes as expected. I put in another part. It indexes. What I'm going to do is I'm going to fill up the machine, and then I'm going to break the door curtain, and you're going to see that it will recover from there. Now I put in another part, and I'm fully loaded. But now, let's say I'm running production, and all of a sudden the Epson has some problem with the screw fastening in this case, and I have to open the door. So what I do is I open the door, and you can see immediately I go into an e-stop condition. If the robot was moving, it would stop. If the table was moving, it would stop. This is a full dead stop. Operator is now safe to enter. Light tower indicates red. HMI in red. Fixture ends up red. Now, I had an error on my process. I clear out the part. I fix the problem. I close the door. Then I go back to my HMI. I hit reset. And you can see the two parts that are still in the machine. Any parts that are not under process and not in the loading position maintain their tracking in the HMI. Now I can hit auto. I can hit start. Camera takes a picture. Robot homes. I put in a part. And just like that, I'm back into production. Next feature I want to demonstrate is the e-stop or the light curtain braking and stopping of the table. So what we're going to show here is how the operator is protected from the movement of the table, so they don't get pinched or nothing happens. The fixture doesn't grab their hand. So what I'm going to do is I'm going to put in a part. Table's going to be moving. I'm going to break the light curtain. So you can see here again it has two parts there. I'm going to put in another part. It's going to index, but this time, I accidentally or I have to break the light curtain for some reason. You can see the table is stopped in mid movement, fully stopped. You can see the HMI indicates that it's in an auto recovery. It will not move until I remove my hand from the light curtain. There'll be a brief pause while the table recalibrates, comes back to home, and you can see three parts. There's still three parts in the table, and off we go again. So we're protected from the motion of the table. And that's it. Thanks for watching.